All right, so we've been talking about finding the domains of functions, and what I've been trying to stress is the first thing you want to do when you're looking at these functions is try to kind of think logically about, where would be the holes in the domain, where would be the problem areas. And we saw, like for this function h, that if you had a negative number, and you can kind of tell that by looking at what's going on here, that if you have a negative number or if you have a floating point number, that as you go back and back and back, subtracting by 1, if you start out below 0, you're never going to end. You're just going to keep going over and over and over, recursively calling this h of x minus 1. And the same thing if you come in with a floating point number, you're never going to hit exactly 0. Okay, so and we said also that you could fix this problem and make this, actually then the domain would be, all the any integer or floating point number that you care to put in, you could stick in this case, right? So and that's part of the reason for this exercise is you want to be, cognizant of these things. You want to write functions that aren't going to die on you if some odd number gets put in, or at least you want to be aware of, when this function is going to have problems, so that you can, make it clear to anybody who wants to use that function, right? So that's one way that we looked for holes. Another thing that we did was we saw that, for example, you'd have a hole in your domain if you tried to do this, right? Because you can't have a denominator that's 0. And if your x was 4, then x minus 4 would be 0 here. Okay, and we saw a way of fixing this, that this could be fixed too. When it's just an individual point that's the problem, you can do something like this. And now you're, when x is 4, before you even get to this line, you do this test and return a 0 right away. So now 4 is in your domain, okay? And then finally, I guess the thing you can do, you can also take advantage of, using Python to do testing. But again, you want to be careful. You want to make sure that you look at these things logically first, so that you don't miss any test cases. Okay. So let's say you've kind of looked at your function a little bit, and you want to kind of test it out and see if you've figured it out. And so one thing you could do is write some functions to test it. Okay, so I wrote this for all these functions, including the square root function. That so these were all the functions from the chapter. The ones that were. So I defined all those guys from the chapter, and then I said for all these functions, I'm going to test the domain. I set up a domain list. So this is going to be a list of actually this is a list of all the guys that aren't in the domain, because I'm interested in seeing when does this fail, right? So this is the list of all the inputs that aren't part of the domain. Okay, so I'm checking to see if it's not in the domain here. So I'm going to go through for x in the range of -10 to 10. Now see, this is the thing. You have to pick a range here of what you're going to test, and I'm actually dividing by 2, so because I want to get some floating point numbers in my test. So I decided I'm going to test from -5 to 5, and the reason I did that was for these functions. That looks like that's a reasonable thing to do, because like if I'd had x minus 20 in here, then 20 better be one of the numbers in my test, right? So I can get an x minus 20, so I can get a 0 in the denominator. So again, you need to be careful about how you're looking at these, or if this was, if x equals 100, well, it's not going to work for numbers under 100, but it will work for numbers 100 or bigger, right? So again, you need to be really cognizant of, thinking logically about these things first, and then, putting in your tests. But so I run these tests and I check to see if some value is in the domain of the function. So the way I check to see if something's in the domain of the function is with this this try except structure. So so first let me talk about that, because if you're not familiar with it, this try except, the way this works is you try to do these statements, you try to execute these statements, and if you get some kind of an error, what'll happen is, usually what'll happen is if you get an error, you'll do what? Let's see, make sure I have math in here. So I'm going to purposely get an error. I'm going to say math dot square root of -4. Okay, usually when you type something in that gives you an error, it'll get spit out like this in the shell. If you do this try except business, what will happen is if one of these errors is the one that's generated, so you can put whatever errors you want, if they're, assuming they're valid, errors. So for example, I know that this gives me a value error, right? So if it's an error, if it's a reasonable error, you can list it in here and with except, and then if that error is raised by anything that happens in this try part, then you'll just go ahead and execute whatever you have in the except part. Okay, so it's kind of like if else, but it's like if there's some kind of an error raised, one of these errors raised, then you're going to jump down here and do that. Okay, but you always try to execute everything that's in the try block, and then if you can't because of some error, then you execute what's in the except block. Okay, and so what I do is I get the name of the function, and I get the function, and I get the input that I'm trying to give the function. I try executing it, and then I check to see if y is a number. And this isNumber function is actually in the appendix, so you need to import the appendix to have this. And then if it says, so if it's not a number, I'm going to return false because I didn't get a number back. Okay, and if anything in here fails, if I get some kind of an error, then I'm going to return false, because that means that there was some kind of error, like for the square root, like for this error. If I got an error, then that means the -4 is not in the domain, right? So I'm going to say, false, it's not in the domain. But then if I tried this and it didn't return, because so that means y is a number, right? And I didn't get an error, then I'm going to return true. Okay, so basically this in domain is your test to see if x is in the domain of f. All right, so, and in test domains, I'm just looping through in this range and just testing them all, and then I keep appending to this domain list for all the values that are not in the domain. Okay, so just to show you what this looks like, let's see, let me just do a run, test domains is the name of this thing. And so what it does is it says, okay, so for function f, which was this guy, it gave back an empty list. That means everything that I tried testing worked. But for g, which notice has this division by x, if x is 0, if it's going to fail, right? So that one is in the list. So again, you can do this kind of testing to try out the different cases, but you need to look at the functions logically first to make sure that you're testing all the possibilities.